If you're a software engineer, you know that the technical interview can be, well, a beast. But what if you had a clear toolkit to tackle it? Today, we're boiling down a 5-hour masterclass into the 5-minute action plan you need. Let's get right into it. So, have you ever opened up LeetCode, seen that wall of hundreds of problems, and just felt completely lost? Yeah, you are not alone. It feels impossible. The real question isn't, can you solve them all? It's, how do you practice smart, not just hard? And that's exactly what we're going to cover. We've taken a massive 5-hour deep dive on this stuff and pulled out the absolute essentials for you. We're not about memorizing answers here. We're focused on the patterns and, more importantly, the mindset you need to solve pretty much any problem they throw at you. Okay, let's start building that toolkit. Before you even think about writing a single line of code for a specific problem, there are two big picture concepts that you absolutely have to nail down. This is the foundation for everything else. The source we're looking at calls this step 0, and honestly, it's critical. Think about it. We live in a world of nonstop notifications, pings, and distractions. The ability to just sit down and focus, truly focus, for a solid block of time, that's a genuine superpower. It's how you'll actually learn and internalize these concepts. All right, next up, Big O notation. I know, it sounds kind of intimidating, but I promise it's just a simple way to talk about efficiency. All it does is answer one question. If I give your code a ton of data, how much slower does it get? Does it slow down a little bit, or does it just grind to a halt? Understanding this is without a doubt non-negotiable for interviews. And this table right here makes it super clear. Let's say you're just looking for a number in a list. In the worst case scenario, you've got to check every single item, right? So if the list has 10 items, it takes 10 checks. If it has 1,000 items, it takes 1,000 checks. The work grows in a straight, predictable line as the input, which we call n, gets bigger. That's what we call O of n, or linear time. Simple as that. So now that we've got our foundation poured, the next tool we're adding to our kit is a repeatable framework. Think of it like a mental checklist for tackling any coding challenge an interviewer can dream up. Now, this is so important. Your first instinct is probably to just jump in and start coding. You have to resist that urge. First, make sure you actually understand the problem. Ask questions. Then, talk through your ideas out loud. And here's the key. Start with the dumbest, most obvious brute force solution. It shows you're thinking systematically. Only then do you plan out your better, more elegant solution. A framework is great in theory, but let's actually see it in action. We're going to take a classic interview problem and run it through these steps, from start to finish. Let's get our hands dirty. Okay, here's the problem. You're given a list of numbers. You just need to tell me, is there any number in there that shows up more than once? If yes, return true. If not, false. Seems easy enough, but in an interview, they don't just care if you can solve it, they care how you solve it. The efficiency is everything. So, sticking to our framework, let's start with the brute force idea. What's the most straightforward way to do this? Well, you could take the first number and compare it to every other number, then take the second number, compare it to all the others, and so on. It'll definitely work, but you can feel how clunky that is, right? And that clunkiness has a name. Because we have a loop running inside another loop, our complexity is O(n) squared. So if our list has 1,000 numbers, we're doing roughly 1,000,000 comparisons. That is not gonna fly. It doesn't scale well, and any good interviewer will spot that immediately. This is the pivot point in the interview. You've identified the brute force way and its flaws. Now, the interviewer is thinking, okay, how can they optimize? The big bottleneck here is that we keep rechecking things. So, what if we had a way to just remember the numbers we've already come across? And boom! This is where knowing your data structures is like having a secret weapon. The perfect tool for this job is a hash set. Its superpower is that you can ask it, hey, have you seen this item before? And it gives you an answer instantly. We call that O(1), or constant time. It doesn't matter if the set has 10 items or 10 million. The lookup is always super fast. So with our new tool, the whole algorithm gets way simpler. We just walk through the list one time. For each number, we ask our hash set, have you seen this before? If the set says yes, we're done. We found a duplicate. If it says no, we just add the number to the set and move on to the next one. So clean. And just look at that difference. We went from that slow, clunky O of n squared solution to a fast, sleek O of n solution. We only have to go through the list one single time. This is exactly the kind of leap, from brute force to optimized, that interviewers want to see. It shows you really know your stuff. All right, you have the foundation. You have the problem-solving framework. The last piece of the puzzle is knowing how to practice, so this whole process becomes second nature. Now listen up, because this might be the most valuable and maybe most counterintuitive piece of advice in this entire explainer. Do not spend hours banging your head against a wall on a single problem. If you're stuck for more than, say, 15 or 20 minutes without making any real progress, just go look at the solution. Seriously, your time is way better spent learning from the answer than just spinning your wheels in frustration. But, and this is a huge but, looking at the solution does not mean copy-pasting and moving on. You have to actively deconstruct it. Write the code out yourself by hand to build that muscle memory. And as you do, ask yourself, what was the key insight here? What was the pattern or the data structure I missed? Write that down. And then, the most important step, come back a day or two later and try to solve it again, from scratch, without looking. And really, that's the whole point. The goal isn't to memorize hundreds of individual solutions. Who could do that? The goal is to master one reliable, repeatable process that you can apply to any problem you face. It's about mastering the framework, not the trivia. So as we wrap this up, just remember that you now have the foundation, the framework, and a strategy for practicing with purpose. The only question left is, what's the one pattern you're going to go out and master next?